Hi guys, this is SB from Skill Builder. On today's lesson, we will be discussing about structures, which is a part of C programming fundamentals. So far we have actually discussed about arrays. We have discussed about what are the limitations of arrays, such as its size being fixed, it being homogeneous in nature. So we'll try to resolve all those problems one at a time using structures. So to start off, first let us understand what is the basic concept of structure. A structure is a heterogeneous user-defined data type. It means that we in a structure we can have elements which belong to different type. For example, in an array, when we were having data items, let's say if the array consisted of 5 items, if one of the items was an integer, all the items were supposed to be an integer. So if we had a character array, if one element is a character, all the other elements were also supposed to be a character. But in a structure, we can have combinations of different data items. For example, we can have a structure in which one item is integer, another item may be a float, another item may be double. Then we can also have integers again, so on and so forth. A structure variable can contain data of different type. These are grouped together in single entity. So just like an array, that is also a collection, but it is a heterogeneous collection. Synthetically, a structure is created using the keyword struct, and we give the structure name, which is optional because it is enclosed within the square brackets over here, as you can see. So the name of the structure is optional. However, it is a good programming practice to give the name to a structure. It is like we create a data type of our own and we give a name to that data type. So with the definition of the structure, inside we have to say which kind of variables are going to be there. So we have the data type of the first variable and the name of the variable, the data type of the variable and the name of the second variable, so on and so forth. And towards the end, we can also mention the actual variables that are going to be of the type structure. I'm going to illustrate this in a while with an example. Proceeding forward, there are some rules for declaring the individual members of the structure. The individual members may be of any basic data type, like it may be integer, it may be a float, it can be character or double, etc. Like I said, you can even have pointers as members of the structure, arrays as members of the structure, or even other structure. All the member names must be unique. They can be of same as those declared outside the structure. So you can have integer a outside the structure, and inside the structure you can also have integer a. But inside the structure itself, you cannot have integer a and integer a. I'll illustrate this as well when I start with the example coding. Individual members cannot be initialized inside the structure declaration. So to say, because a structure is like only a definition, it's like a blueprint which actually does not consume any space in the memory. It's just a definition for a user defined data type. So since it does not consume actual space in the memory, we cannot initialize the variables of the structure inside the structure itself. So when we do the programming example, that will get clarified as well. So proceeding forward, let me start off with the creation of the structure. So hash include just like a normal variable, just like a normal program, I'm going to create integer variables like integer a, and I'm going to use clear screen function. I'm assigning any random value to a. And So this is what we have done so far, and we already know about this. So I'm going to call it struct.c. I compile the program, there are no errors, and I'm running the program, and I see, as expected, I'm printing the value of a. So when this happened, when we are executing this program, we are creating a variable called as a, so it's of type integer. As we know that this is a normal variable, so it can only hold one data of the type integer at one particular time. If I want to store more than one variable, more than one values with the same name, then we have to create an array. So that is what we have already discussed so far. Because if I don't create an array, I might have to, I will have to create other variables like a, b, c, d, and e, and so on and so forth, which is a tiresome process. So I go ahead, and for storing 5 members, I'm going to create an array of 5 elements. So now, instead of saying a is equals to 5, what I can do is I can have a loop variable integer I for I equals 0, I less than 5, I plus plus. It's a simple loop for accepting for initializing the values inside a array. A of I is equals to, let me just provide I plus 10, let's say, just say. So the first element will have 10, the second element will have 20, 30, 40, and 50, so on and so forth. So that is how we are going to do, and let me print the array as well. For I is equals to 0, I less than 10, I less than 5, sorry, I plus plus. Printf percentage d slash e. This is just for printing a tab, and I'm printing a of I. Compiling the program and executing it. So as you can see, 10, 11, 12, 13, and 14, this is happening because the variable is having, I variable is having 0, 1, 2, 3, and 4, and I'm incrementing, I'm adding that with 10, and so we have 10, 11, 12, 13, and 14 going into the locations of the array. But this time, as you notice, that this array being homogeneous, it can only have integer data. However, in real world, the data is complex in nature, which means that it will not always consist only of integers. A particular data, for example, if I take student information, the student has name, which is a string, it can have a roll number, they can have marks of individual subjects, which can be integers, they can have percentage, which is a floating point. So when we want to store heterogeneous data with the same name, arrays do not suffice. So for that, what we can create is we can have again the separate variables for storing name. For example, I can have a character array char n 30, let's say, for storing the first name, or let's say for storing the name itself altogether. I can have float percentage for storing the percentage of a particular student, let's say. But then, if with this I can only store the data of one student, but if I want to store the data of another student, I'll have to again create these variables all over again for that particular, for a new student. So as you can see, the complexity of the program will increase. So we'll have to keep on creating new sets of variables, new sets of variables for one particular student. So instead of doing that, what we will do now is we will create a structure or data type of our own, and that data type will be capable of storing data of an individual student. So for that we use a structure. So let's see, to define a structure we use the keyword struct. So it's like I'm creating my own data type. So I'm saying student. So I want to create a data type called as student, and this student can contain, let's say, integer roll number, and just to keep it simple, integer marks. So now any variable which will be of the type student will contain roll number and will also contain marks. So in the program what I'm going to do is I'm going to create a variable now called as marks. So if I were to create an integer variable, I would have said integer a, but because I don't want to create an integer variable, I want to create a variable of the type student. So I'm going to say student s1, let's say. So s1 is the variable and its data type is student. So s1 is the variable and its data type is student. But then when I save it and compile it, it gives me errors and warnings. So let's check out what is the error. Too many types in declaration, that is the first error. I think I have to give a semicolon over here somewhere. Yeah. So now the error is actually undefined symbol student. So over here it says that it does not recognize what this student is. Why? Because student is a user defined data type. Now it's a structure. So we have to assign, we have to tell the compiler that this is actually a structured data type. So we have to use the keyword struct student s1. So with that the errors are gone. So what I'm doing is actually I'm creating a variable called as s1 of the type student, and because the compiler does not know what student is, we have to prefix the keyword struct in front of it. So this student is the data type. Now remember I told you that when we create a structure, it actually does not consume any space in the memory, which means that if I do not declare any variables of the type structure, let's say this line did not exist. So if I do not have any variable of the type structure, then it is merely a definition. This integer and integer roll number and integer marks is actually not consuming any space in the memory. But then the moment I declare a variable of that type structure, this s1 is going to consume some space in the memory. How much will that space be? It will be 2 bytes for integer and another 2 bytes for marks. So that will be 4 bytes in the memory. So I can verify that by actually printing printf. I'm going to use the size of function, %d, comma, size of s1. So I want to see how much space is this s1 consuming in the memory. When I do that, let me compile the program and execute the program. So it says 4. This 4 is coming because this s1 has 2 values inside it. One is for roll number and one is for marks, and each being 2 bytes in the memory. So it is consuming 2 bytes plus 2 bytes, which is 4 bytes. Let's assume that marks was a character variable just for demonstration purpose. So if I have char marks, so marks being 1 and integer being marks being a character variable which consumes 1 byte in the memory, and roll number being integer which consumes 2 byte in the memory, so that is 2 plus 1 is 3. So now when I do size of s1, which is size of this particular variable which is of the data type struct student, so it should show 3. Let's verify that by executing this. So it shows 3, which means program so far is correct. Let's again revert back to making marks as integer. So now we have verified that this variable, which is an instance of this particular data type called a student, which is actually a structure. So This particular data type is by itself not consuming any space in the memory. It is only consuming space when an instance is created. If the instance is not created, it is merely a definition. So to illustrate that, we can look at a real life example. Let's assume that we want to create a building of our own. In order to create a building, first a blueprint is created. In pen and paper, we draw the sketch it out how the building will look like. That paper itself is not going to consume a physical space as much as a actual building would consume. So the blueprint itself can be folded and put it inside a pocket. But once we actually make a building out of that blueprint, a model, actual physical model of that blueprint is made, then that building is going to consume the space, but the blueprint itself is not going to consume any space in the memory. So that is the basic idea behind structure. So right now this structure is still homogeneous in nature because I'm having both integers and integer mark. But if I wanted to store something like float percentage, let me also have name, character array for name, char n20. So we are using a character array for accepting name. So now if I check the size of s1, so it should take 20 for the character, and for float it will take 4, so that is 24 plus 2, that is 26. So let's execute, and it shows 26 correctly. Of course we don't want to always print the size, so let's get rid of this. Now let's see that this s1, if I want to assign some values to s1, how do I say that s1 has a roll number of 1, s1 has a name which is x, s1 has a percentage which is so on and so forth. So to do that, we use the name of the variable. In order to access the individual member inside the structure, we are going to use the dot operator. So we say s1 dot roll number. So we use the dot operator for accessing the individual members of a structure variable. s1 dot roll number is 1. I can of course use the scanf function for accepting number from the user, and then I say let's say scanf is percentage %d and so on and so forth. So I can actually do something like this: printf enter the roll number, and then we do scanf percentage %d, comma address of s1 dot roll number. So what we are doing is just like any normal variable, in the individual member is being accessed, but of course the name of the variable, structure variable, followed by the dot operator has to be used. The same thing we are going to do with printf enter the name, and I'm going to use the getIs function for accepting the name, and I'm going to say s1 dot n, and we have already studied the getIs function, so I'm not going with the explanation with that. For that, printf enter the percentage and I do scanf percentage f and address of s1 dot percentage. So now I have accepted the numbers from the user. Let me compile that. There are no errors so far. Now let me just printf percentage d with a slash n. I am going to the next line and I'm printing name is percentage s with a slash n. Again I'm going to the next line. Sorry, I should not be using percentage d. With this much I should be done. I will print the s1 dot roll number. Printf name is going to use the put s function for printing the name s1 dot n. Printf slash n. Percentage is percentage f and s1 dot percentage. So what I'm doing is I'm simply accepting some values from the user and I am printing those values. So there are no errors. Let's compile the program. There is an error. Let's see. So there is some error in the I missed a T somewhere. Let's compile the program and let's run the program. So it asks me to enter the roll number. I'm entering 1. Asks me to enter the name. It did not accept the name because I forgot to flush out. Enter the percentage and I enter 12.5 and then it prints the roll number. The name is not printed and the percentage is printed. There's something wrong with the name. Let's go ahead and check. We had discussed the function fflush in the previous lecture. Let me include the header file. So as you can see that the roll number, name and the percentage is getting printed correctly. So that is the basics of a structure. So if you look, what I have done is I have created my own data type, which is a heterogeneous type. It contains an integer, a character or a float. Now if I want to create another student, all that I have to do is say struct student s2. So this creates a new variable of the data type student. So we have s2. So same way I can accept the values for s2. I can do the accepting of values for s2 and then I can also print the values for s2 the same way with using the printf scanf combination. I can print the values also. So as you can see, if I want more variable of the type student, I can simply say struct student s3. I could do all these in one line itself also, saying s1, s2, s3. I could have done like this also and I wouldn't need all these. So now what we have done is we have created a data type of our own, which is of the type data type actually would not be the right term to say, because the data type actually contains something called as operations also. But just for understanding purpose, it's more or less like a user defined data type. A structure is more or less like a user defined collection which contains of heterogeneous items. And as I mentioned, the important thing to understand is that the definition itself does not allocate any space in the memory. It is only when we create the variable of the type, that variable is going to consume some space in the memory depending on how much space was allocated for it in the memory. So that is how we create a structure, and we create variables of that structure, and we initialize the variables of that structure. Now, of course, this is just three variables of the type structure. Again, the same problem with array is coming, that we had seen why we used array was, array is actually a homogeneous collection, and we needed an array. Let's say if I wanted to store data about 5 numbers, so instead of creating 5 integers separately, I created one array of integers. But the array being homogeneous in nature, it did not help us solve the problem of heterogeneous data. So we created something called a structure for storing heterogeneous data. Now let's say if I want data of 5 students, instead of creating 5 separate structure variables S4 and S5, I could simply create one variable called as S, an array of the structure variable. It's just like a normal array, only thing is now its individual members are structure elements. So S0 contains a structure element. So S0 contains a roll number, a name, and a percentage. S1 contains a roll number, a name, and a percentage. S2 contains a roll number, a name, a percentage, and so on and so forth. So that's how a array of structure is created. So let me revert back. So let's look at the program once again. These are header files used in the program. This is the declaration of the structure, the definition of the structure. This is where the variable creation of the structure is happening. So S1 is a variable of the type student, which is actually a structure. Remember, if we do not mention the keyword struct, the compiler will give an error saying that it does not understand what this student is. So that is why we had to mention the keyword struct. There is a workaround to this. We use something called as a typedef keyword, which is a part of the next lecture. So we will be discussing something called as typedef in the next lecture, and we will see how to get rid of this pesky little struct keyword over here. And as we already know, clear screen is for clearing out the screen, and over here we are simply accepting the numbers just like the normal old school way of printing and scanf combination. F-flush I've used just so that I can clear out the standard input, and we are flushing out the previous whatever junk values were there in the standard input, so that I could actually accept the name, and so that I could accept spaces also in the name. I'm using a getis instead of a scanf, and we are printing the data. So that is what structure is basically about in short. So let me close this program and get back to okay. So we saw that the individual members can be of any type: integer, float, character, double. We can even have pointers or even arrays inside the structure as members. When I'm saying arrays or even other structure, I mean they can themselves be a member element of the structure. So we will be looking at that, and we will also be looking at how to nest the structures in the upcoming lectures. But for now, this is how a structure is created. This is a sample code for creating a structure called a student, and it contains a roll number, subject, marks, and over here we are directly creating variables: student1, student2. These are actually variables of the type student. So we can omit that as well by putting a semicolon. I generally do not declare the variables of the type structure directly when I'm doing the declaration of the structure, the definition of the structure, I mean. I also said that the keyword, the name of the structure is optional. This we can do only if we are declaring the variables of that structure along with the definition of the structure. If we are not giving any name to the structure, and we are creating variables, it is acceptable. This is not a compiler error. However, if you do not give the name of the structure and you do not declare the variables over here, rather you declare it somewhere else, you say struct and student1, this is going to create a problem saying that student1 needs to know what type it needs to be. So these are both working code, these are both working variations, acceptable variations of structure declaration. So this is what I meant, that you can actually keep the variable declaration of the structure separately. That is what we had done in the example program. And interestingly, we can also actually assign values directly in one line, just like we would do with a normal array. So because it's a collection, so we could actually give it the values directly like this. So it has 10, 101 and 88.0. This is actually going over here. So the student 1 will have roll number as 10 and subject would be 101, which is the subject code, and marks would be 88.0. That was what was going over there. As I showed, we can actually use the printf scanf combination to accept the values from the user and do normal processing as we would do with any normal program. We can also create arrays of structure, which I had demonstrated. So array of a data type of student is created as 10, and then we can do something like this, s0 dot roll number is. So individual elements of the structure can be processed in this particular way. So this is a very handy tool for creating an array of structure, something called as an array of structure, which is a very handy way of doing it. We can also nest a structure within a structure, which we are going to discuss in the upcoming lecture. For the time being, what we will do is we will create a structure as an assignment. We will create a single structure, and these are something which we will discuss in the upcoming lecture, the typedef keyword, how to actually create an array inside a, how to have array inside structure. So a structure, array of structure, when I say array of structure, I mean something else, and when I say array as an element inside a structure, I mean something else. So which we are going to discuss in the upcoming lecture, using the typedef keyword to get rid of the struct keyword over and over again, or how to have arrays and pointers as members of the structure, and how to create a self-referential structure, something which is a very, very powerful concept in C programming. So what we would do is our assignment is to create a simple structure called as person, as employee, with elements as employee ID, which should be numeric. We will have the employee name, which can be a character array, which should basically be a string. Should have designation, which would be again a character array, again a string. Could contain data such as manager or clerk, and so on and so forth. These are just examples. Would also contain a column for salary, which could be floating point, and could also contain let's say gender. So our objective would be to create definition of this structure. Gender, by the way, can be a single character, so we can have character. So our objective would be to create an array of, or let's say create 10 employees and assign and ask the user to input the data and print the data in a tabular format. Print the data in a tabular format, which means that eventually it should look something like this. So the employee number employee number should come, employee name should come, then we have employee ID, that should do employee number, employee name, then the designation, then the salary, and the gender. So it would look something like this: employee number is so on and so forth, employee name is XYZ space XYZ, let's say ABC, designation is manager, let's say salary is 1 2 3 4 5 6, gender is M. So we could have for 10 of them data to be displayed. So that is the assignment which needs to be completed. I'll see you guys in the next lecture.